Hello, welcome to the first of two AS Pure Maths revision videos. This one, I'll cover some basic algebra, sketching graphs, coordinate geometry, factor theorem and binomial expansion. We'll start with an indices problem. My first tip, given this type of problem, is to convert all your numbers into products of prime factors. So here we'll have 2 to the 5th to the power of 3/5, which equals 2 to the power of 3. If we raise a power to a power, we multiply the indices. The second part, we have a negative power. Negative powers are reciprocals. So we flip the fraction. It gives us 2 squared over 5 squared x to the 4th to the power of a half. That gives us 2 over 5x squared. Similarly with surds, converting the numbers into prime factors, we get the square root of 50 minus the square root of 18 equals the square root of 2 times 5 squared minus 2 times 3 squared. We can take the 5 and the 3 outside of the surds to give us 5 root 2 minus 3 root 2, which is 2 root 2. For the second part, it's a hence or otherwise, so we're going to use the result in part A to give us 12 root 2 over 2 root 2. The 2 will cancel with the 12. We multiply top and bottom by root 2. And we can simplify it to be 3 root 6. Notice that we've been asked to put it in the form of b root c, which is why we didn't leave it as 3 root 3 root 2. This one is a problem relating powers and also quadratics. We're asked, given that y equals 2 to the x, find 4 to the x in terms of y. So 4 to the x will be 2 squared to the x, which is 2 to the 2x, which will be 2 to the x all squared, which equals y squared. So 4 to the x equals y squared. We're asked, hence or otherwise, to solve this equation. So here we substitute y equals 2 to the x. This 4 to the x will be y squared. 2 to the x will be y plus 1. We get a quadratic in y, which we can solve by factorisation. So we get y equals an eighth, which equals 2 to the x, and y equals 1, which equals 2 to the x. In the first case, x equals minus 3. In the second, x equals 0. You'll need to solve simultaneous equations. Here's an example of one linear, one quadratic. We're going to rearrange the linear equation so that one variable, in this case y, is expressed in terms of the other. And we're going to substitute that into the quadratic equation. Expanding and simplifying, we get a quadratic in x. It factorises, we get the first value for x is minus a half, y is 3. The second value for x is minus 4, in which case y is also minus 4. Here's another simultaneous equation question, but this time is combined with the use of the quadratic discriminant. We're given these two simultaneous equations, where now k is some non-zero constant. And we have to show that the quadratic we get when we eliminate y is x squared plus 8kx plus k equals 0. So we rearrange the linear equation to get y equals 1 minus 2x. We substitute into the quadratic equation, we expand and simplify, and we get the quadratic as requested. We're then told that this quadratic has equal roots. Let's just recall. With the quadratic formula, the part under the square root, the b squared minus 4ac, determines whether the quadratic has 2 real roots, in the case of it being greater than 0, whether it has equal roots when the discriminant equals 0, or whether it has no real roots, that's when the discriminant is less than 0. Coming back to this case, it has equal roots, so the discriminant must be 0. So the b squared, 8k squared, minus 4ac minus 4k equals 0. So from this, we see that k equals 16. We substitute this back into the quadratic for x to get x squared plus a half x plus 16 equals 0. This factorises to a perfect square, which you'd expect, given that there's equal roots. X plus a quarter all squared equals 0. So the solution to this is x equals minus a quarter. We substitute this value back into the linear equation to get the corresponding y value of 3/2. Inequalities. First part of this question. Find the set of values for which 3x minus 7 is greater than 3 minus x. So we add x to both sides. We get 4x minus 7 is greater than 3. Add 7 to both sides. 4x is greater than 10. Divide both sides by positive 4. We get x is greater than 2.5. Part B is a quadratic inequality. Here we need to move all the terms onto one side. So we get x squared minus 9x minus 36 is less than or equal to 0. We can factorise it. X minus 12 times x plus 3 is less than or equal to 0. I'd normally sketch a graph of the left-hand side, x squared minus 9x minus 36. We can see this graph here. We have the two roots at minus 3 and 12. And we can see that it's less than 0 between the values of minus 3 and 12. So for x squared minus 9x minus 36 to be less than or equal to 0, x needs to be between minus 3 and plus 12. And then finally, for both of the inequalities to hold, it means that both x has to be greater than 2.5 and x has to be between minus 3 and 12. So for both to hold, x has to be strictly greater than 2.5 and less than or equal to 12. This question is about transformations and sketching of curves. We're shown the graph of f of x equals x plus 3 squared times x minus 1. We can see that it's going to be a positive cubic. So it will start in the bottom left and finishes in the top right-hand corner. It has a duplicate root where x equals minus 3, which is why the hump of the curve touches the x-axis at minus 3. It has a single root at plus 1, which is why the curve cuts the x-axis at x equals 1. Substituting x equal to 0, we get f of 0 equals minus 9, which is why the curve cuts the y-axis at minus 9. We're asked to sketch the curve with the equation y equals f of x plus 2 and state the coordinates of the points where the curve meets the x-axis. Well, f of x plus 2 will be f of x shifted 2 in the negative direction. So it's going to cut the x-axis at the point minus 1, and it's going to touch the x-axis at the point where x equals minus 5. We're asked to write down an equation of the curve C. So what we have to do is we take the equation for f of x, and for every x in the function, we replace it with x plus 2. So simplifying the expressions in each bracket, we get g of x equal to x plus 5 all squared plus x plus 1. So again there we can see we have a duplicate root at x equals minus 5 and a single root at x equals minus 1. To find out where this cuts the y-axis, we set x equal to 0 and we get 25. So the point where the curve meets the y-axis will be 0, 25. Let's turn now to a coordinate geometry question. We're told that a straight line L1 has equation 5y equals 4x plus 10. We rearrange this. Y equals 4/5 x plus 2. We can see the y-intercept is 2 and the gradient of L1 is 4/5. It's also clear from that equation that the coordinates of S are minus 2.5, 0. We're told that a point P with x coordinate 5 lies on L1. Substituting x equals 5, we get y equals 6. So the coordinates of P must be 5, 6. The straight line L2, we're told, is perpendicular to L1 and passes through P. So the gradient of L2 will be minus 5/4, which is the gradient of L1 flipped and turned negative. Find an equation for L2. The easiest form of equation will be y minus 6 equals minus 5/4 x minus 5. We are asked to write the answer in the form ax plus by plus c equals 0, where a, b and c are integers. So we have to multiply through by 4 and rearrange, in which case we get 5x plus 4y minus 49 equals 0. L1 and L2 cut the x-axis at the points S and T respectively. Calculate the area of the triangle SPT. So we're going to take the height 6 and we've got a base of ST. To find T, we set y equals 0. So we have 5x minus 49 equals 0, which tells us that the x coordinate is 9.8. And to calculate the area of SPT, it will be a half of ST times 6. So that's a half of 12.3 times 6, which is 36.9. Let's move on to a circle problem. We're told the circle C has centre P, 7, 8, and it passes through the point Q, 10, 13. We're asked to find the length of PQ, giving the answer as an exact value. Well, this is simple Pythagoras. It will be the square root of 10 minus 7 squared plus 13 minus 8 squared. So that's the square root of 34. We're asked to write down an equation for C. That will be x minus 7 squared, so that's x minus the x coordinate of the centre, all squared, plus y minus 8, that's y minus the y coordinate of the centre, all squared, and that will equal the radius squared, 34. We're told L is a tangent to C at the point Q. So L will be perpendicular to the radius to Q, PQ. So we work out the gradient of PQ is 5/3. Therefore, the gradient of L must be minus 3/5. And we can write down the simple expression for the line L, which is y minus 13 equals minus 3/5 x minus 10. We're asked to write it in a specific form, so we multiply through by 5 and rearrange the equation to get 3x plus 5y minus 95 equals 0. Sometimes the circle questions ask us these things in the opposite direction. We're given the equation of the circle and we have to find the coordinates of the centre and the radius. Here we group together the x and y terms and we're now going to complete the square. So for the x squared minus 10x, that will be x minus 5, half the x term, all squared. We've got to subtract the extra 5 squared. Similarly for the y terms, y squared plus 6y will be y plus 3, half the number of y's, all squared, minus 3 squared. We add the 30 equal to 0. We rearrange this equation to get x minus 5 squared plus y plus 3 squared equals 4. This is the radius squared. So the coordinates of the centre will be 5 minus 3. Take care with the signs because it's x minus the x coordinate of the centre of the circle and y minus the y coordinate of the centre of the circle. And the 4 will be the radius squared, so the radius is 2. We're finally asked to calculate the y coordinates of the points where the circle crosses the line with the equation x equals 4. To do this, we substitute x equals 4 in the equation of the circle. I use the squared one because we've effectively completed the square already. We rearrange to get y plus 3 squared equals 3. We take the square root of both sides and rearrange. We get y equals minus 3 plus or minus the square root of 3. We're going to look at a question on the factor theorem. We're asked to use the factor theorem to show that x minus 2 is a factor of fx, where fx is 2x cubed minus 7x squared plus 4x plus 4. The factor theorem says that x minus a is a factor of fx if and only if f of a equals 0. So we calculate in this case the value of f of 2. We show that it's 0 and therefore x minus 2 is a factor. In the second part, we're asked to factorise fx completely. So we do that by performing a long division, dividing f of x by x minus 2. Let's go through the steps of the long division. First up, we ask what do we multiply x by to get 2x cubed? And that's 2x squared. We take this 2x squared and we multiply it by x minus 2. So we get 2x cubed minus 4x squared. We subtract it from f of x. That leaves us with minus 3x squared. We bring down the 4x. Next we ask what do we multiply x by to get minus 3x squared, and that's minus 3x, and we multiply minus 3x by x minus 2. That gives us minus 3x squared plus 6x. We subtract it from the row above to get minus 2x, and we bring down the 4. We ask what do we multiply x by to get minus 2x. The answer is minus 2. We multiply minus 2 by x minus 2 and we get minus 2x plus 4, which when we subtract it from minus 2x plus 4 gives us 0. So this is the remainder, a remainder 0 when we divide the polynomial fx by x minus 2. And this is the quotient 2x squared minus 3x minus 2. So f of x equals 2x squared minus 3x minus 2 times x minus 2. We can factorise the quadratic, 2x plus 1 times x minus 2, and we can group the x minus 2 terms. So we get a final factorisation of 2x plus 1 times x minus 2 all squared. We're going to look now at two questions related to the binomial expansion. Remember that in the formula booklet there's a recipe for the binomial series. We want to expand 2 minus 3x to the power of 6. So we have to identify a, b and n. So we get the a is the 2, b is minus 3x and n is 6. We substitute those values into the recipe in the formula booklet to get 2 to the 6th plus 6c1 2 to the 5th times minus 3x plus 6c2 2 to the 4th minus 3 squared x squared plus ... So these are the first three terms. We calculate them using a calculator and we get 64 minus 576x plus 2160x squared. Part B of the question says hence or otherwise find the first three terms in ascending powers of x of the expansion of 1 plus x over 2 times 2 minus 3x to the power of 6. So here we need to take this series representing 2 minus 3x to the power of 6. We multiply it by 1, then we multiply it by x over 2. Notice we only take the first two terms, 64 times x over 2, 32x, and minus 576x times x over 2 minus 288x squared. We don't need to take the term x over 2 times 2160x squared because that will contribute to the x cubed term. We take these two, we add them together, and that will give us the first three terms of the power expansion of 1 plus x over 2 times 2 minus 3x all to the sixth. Here's another common form of question related to the binomial expansion. We're asked to find the first four terms of the binomial expansion of 1 plus x over 4 to the power of 8. Again, we refer to the formula booklet for the recipe. We want to expand 1 plus x over 4 to the 8th. We identify a is 1, b is x over 4, and n is 8. We substitute these into the recipe that's given, and we calculate each of the coefficients. So in this case, we get 1 plus 2x plus 1.75x squared plus 0.875x cubed. The final part of the question asks you to use the expansion to estimate the value of 1.025 to the power of 8, giving the answer to 4 decimal places. Here we want the 1 plus x over 4 to be equal to the 1.025, which means that we need to set x equal to 0.1. So here we substitute x equals 0.1 into this expansion, sum the terms to give an approximation of 1.2184. That's it, guys. I hope you found it useful. Please take a look at part 2, which will cover trigonometry, vectors, differentiation and integration, exponentials and logarithms.